Alright, for this third video, now we're going to talk about sample size that you need. Because you do have a minimum sample size to actually, for this to actually be true. So sample size is generated from the margin of error. So if you remember the confidence interval formula, right? It's the confidence interval formula here. This part is the margin of error. So the margin of error, if you notice, right, this is margin of error, has a sample size in it. Okay? So if you want to improve things, you need more samples. Okay, so let's take this right here and solve it for n. Okay, so this is really a multiply right here, correct? Alright, let's just make this bigger and go from there. Alright, so what I'm going to do is I'm going to divide both sides by the z value. Okay, and what that'll do is that'll just get rid of the z on the right hand side. Okay, so the next step is, again, I'm solving for n, right? Keep in mind what we're doing. We're solving for n. I want to get rid of the square root so I can get n by itself, right? So I'm going to take this, and I'm going to put this in parentheses, and square it, and put this in parentheses, and square it. The result is, you get this on this side, but on the right side, the square and the square root cancel, right? So now I'm left with this. So again, I'm trying to solve for n, but the n's in the denominator. So I can do a couple things here, but I think I want to flip this first. What I'm going to do is I'm going to take this, copy, paste. I'm going to flip this. I'm going to put this on the top. I'm going to put the margin of error on the bottom. So if I flip one, I have to flip the other. So therefore, this is going to go to the bottom, and then the n is going to go on the top. Because if you flip both ratios, it's still equal, right? Okay, so the last step is to get rid of this p and q from this side. So what I'm going to do is I'm going to take this and multiply by p times q on the left side, and multiply by p times q on the right side. So what happens is I get this equals the n, because obviously these cancel over here, correct? So that is the formula to figure out minimum sample size, right? So if you look up here, there's our formula, correct? Okay, so let's do a few examples of minimum sample size. Okay, so we're going to take this to a spreadsheet and then do another page. Paste that in there. Blow this up. All right, so we're going to do p hat equals q hat equals z alpha divided by 2 equals margin of error equals, and then n equals. Okay, so we'll take those, shove them to the right. Okay, so this is our formula here we want to do. Okay, let's read the question. So a researcher wishes to estimate with 95% confidence the proportion of people who do not have landline phones. A previous study found that 40% of people do not have landline phones. If the researcher wants to be accurate within 2% of the true proportion, what is the minimum sample size needed? Okay. All right, so the P here is 40%, because 40% don't have a landline, which means 60% do have a landline, right? Has to add up to 1, right? Because we're calculating non-landlines, that's 40, right? So we want a 95%, I believe is what it said, right? So 95% confidence. So that means 5% alpha. So half of 5% is 2.5, right? So 95 plus 2.5 is 97.5. So normal dot inverse 0.975 comma 0 comma 1. Okay, so the margin of error, what did it say? It says it wants to be within 2% of the true proportion. That's my margin of error. So don't put 2, that's not good. That's 200, we want 0.02. That's how we want to be off by at most. Okay, so sample size using the formula, p hat times q hat times parentheses, the z, divided by the margin of error, all to the second power. Okay, so I get this number here, which is not going to work for us. Right, so if you think about it, I have 2304, 2304.88, and 2305. Okay, it says, obviously this will go out more if you make it bigger, right? So if I make that bigger, it'll get more decimals. This is the minimum I need. So but I can't get a partial sample. I can either have this many samples or I can have this many samples. Right? You can't have this many samples. That's not possible. So if I have this many, I don't have enough because I need minimum this. But this is enough samples right here, right? So you have to go up. It doesn't matter what these decimals are. You have to round up because you need to make sure you have enough samples. This is not enough samples. This is enough samples. So what I really want is 234 samples or more, essentially, is what you want. Okay? All right, let's take this, copy, paste. We can copy paste this again. Let's read the next question. Okay, so what did we get? This is what we got here for this one, right? 2,305 samples or more. Researcher wishes to estimate with 90% confidence the true proportion of people who buy clothing online regularly. A previous study found that 66% of people buy clothing online regularly. If the researcher wants to be accurate within 3% of the true proportion, what is the minimum sample size needed? Okay, so 66% buy clothes online as our sample. So that means 34 don't, essentially, right? So we want a 90% confidence interval, right? 90%. So alpha is 10%, half of that is 5. So 90 plus 5 is 95%. So normal dot inverse 0.95, comma 0, comma 1. All right, so the margin of error, I believe, was 3% this time, wasn't it? What did it say? Yes, within 3% of the true answer. Okay. So my number of samples is the proportion true, proportion false, and then the ratio of z divided by the margin of error squared. Okay, so if I have 674 samples, that's not enough. So I need to go 675 samples or more. The books will actually specify what the samples are in context of the problem. You don't need to do that. You can just say samples or more as to whatever the samples are, whether they're, people or widgets or whatever the case may be. Okay. All right. So essentially here we get. Oh, that's not correct. What did I mess up here? 34.03. I think I just did my math wrong is all. But this is right though. That's the correct number of samples. Okay.